Now, sometimes you can even get a weather observation when there's nobody there to observe it. For instance, when the weather observer goes home for the night, as they are wont to do, sometimes I'm told they even take lunch breaks every doggone day. Or when there is no weather person in the first place, the government often provides automated weather surface observing equipment so you can still get the local surface weather. What that means is that machines, rather than people, actually do the looking for you. Now, these installations are called, and there's two of them, first of all, the Automated Surface Observation System, or ASOS, and the other system is the Automated Weather Observation System, or AWOS. Now, even though the names of these two systems are different, they have similar equipment, and they generally tell you about the same types of information. Now, one difference is that ASOS that we have right here is more sophisticated, and it has more quality control checks. Now, another difference is in who installs and maintains these systems. The FAA and the National Weather Service install and maintain the ASOS system. On the other hand, the AWOS systems are primarily funded and installed by local airport authorities and by state governments. Now, if you want to listen to an ASOS or AWOS observation, you are in luck, because most ASOS and AWOS installations broadcast their information over their own VHF radio frequency. By the way, that's called a discrete frequency, or sometimes they broadcast the information over the voice portion of a local nav aid. Now, one place you can find the frequencies of an ASOS or AWOS is on your instrument approach charts. For instance, here we have an approach chart for Dodge City Regional Airport, and if you look in the upper left-hand corner, the frequency of the ASOS is 118.525. Now, you'll also find the frequencies on the legend of your NOS low altitude en route chart. Here we have Dodge City Regional, and once again, the ASOS frequency is 118.525. How lucky, it's the same frequency. Now, sometimes the ASOS or AWOS information is broadcast over a nav aid frequency, especially when it's associated with an airport. Here we have Thief River Falls. It's in this case a VOR, could be an NDB, but we have a VOR here. Thief River Falls, and if you look in the upper right-hand corner, you see that shaded circle with an A, and that tells you they have ASOS or AWOS information, and you just tune into the VOR frequency of 108.4 to get it. Now, if you happen to be using Jeppesen en route charts, you've got it made, because you'll find the frequency right on the front of the chart with the airport information for an airport. Here we have Tucson Ryan Airport. The AWOS is 118.05. Now, all of this lets you find the frequencies along your route of flight, so you can listen to the automated reports as you fly along and check your en route weather. Now, for your pre-flight planning, you can also find the frequencies in the airport facility directory. Here we have the entry for Liberal Municipal Airport. It says weather data sources and AWOS 3119.95. Now, you can reach many of these systems and listen to them over the telephone as well. For instance, notice right after the AWOS frequency here at Liberal, we have a telephone number, and that is for the AWOS. Now, when you listen to these systems either over the radio or by telephone, what you'll actually hear is a computer synthesized voice.
Bluetooth 50 at 5. Visibility 1.
You know, the first time I heard that, I thought it was a real person with a speech defect. I thought, poor guy, he's got to go through life that way. You know, for pilots, ASOS is a big deal, because ASOS is rapidly becoming the primary surface weather observing system in the United States. Now, ASOS gives you continuous weather observations, and it gives you everything you need to produce a METAR or a SPECI. So let's take a look at what you might expect to get from an ASOS. First of all, you get cloud heights, visibility, precipitation type, pressure, temperature and dew point, wind direction and speed, rainfall accumulation, and at some sites you can get freezing rain information and lightning indications. Now, the remarks section of a METAR will indicate either AO1 or AO2 depending on the type of equipment being used. Here we have AO2, and this AO2 system can identify precipitation as frozen or liquid, but AO1 cannot. Now, as great as ASOS is, and it really is great, it does have its limitations. For one thing, it only reports the weather right at the observation site. So what this means is clouds will only be reported if they're directly right over the top of the reporting station. And also, the way it works is the sensor estimates the percent of cloud coverage by sampling the coverage over the station over time. So if the clouds don't move much, the sensor could interpret, say, breaks in the overcast as clear skies. And by the way, the system also can't tell you the cloud type. For instance, whether it's stratus clouds versus cumulonimbus clouds. And it can't tell you whether the obscuration to visibility is smoke, haze, or fog. And also, if the wind sensor is located somewhere other than the runway, and it has to be, it might tell you winds different than the runway location. And because the information reported is averaged over time, the ASOS information can be somewhat unreliable during rapidly changing weather conditions. So when you're working with an automated weather reporting system like ASOS, a little skepticism and sound pilot judgment is always a must. Now, if you'd like to get the best of both worlds, you team up your ASOS with this, a real live human being, otherwise known as a human observer. Now, a human observer can check the observation for accuracy and make any needed corrections, and they can add information about thunderstorm activity in the vicinity and about freezing precipitation and other significant weather. Now, there are 4 levels of ASOS, and these levels are based on whether there is a human observer and how much information they add. For instance, levels A and B will have human observers available 24 hours a day. Level C only has observers when the tower is in operation, and at level D, the ASOS is always unattended. Now, if there is no human observer involved, the beginning of the METAR will have the word auto, and that tells you no human observer is involved in this thing. Now, the level of service that you'll get at your airport depends on how busy the airport is. Obviously, big airline hubs will have level A service, but also on how remote it is from suitable alternate airports and how frequently your airport has thunderstorms or freezing precipitation. Now let's take a look at the AWOS system. As you remember, the AWOS system is less sophisticated than the ASOS system, and these systems are generally installed by state or local governments. Now you'll also find that there are 4 types of AWOS installations, and each type provides you with a different amount of information. For instance, AWOS A gives you the altimeter setting only, so the A must stand for altimeter. Now AWOS 1 adds wind speed, wind direction, temperature, and dew point to that. And AWOS 2 adds visibility to it, and AWOS 3 adds clouds and ceiling, but does not have precipitation information. Now, the AWOS levels are not indicated in the METAR report, but you can tell which level an airport has by looking on an instrument approach chart or by looking in the entry in the airport facility directory for that airport. For instance, Liberal, Kansas has an AWOS 3. Now, AWOS reports have the same limitations as ASOS reports, and like ASOS reports, AWOS reports can be augmented by a human observer. Now, if no human observer was involved, you'll find the word auto in a METAR report. Knowing the extent of human involvement, if any, in a report gives you a feeling of the completeness and accuracy of the observation, and it tells you how much to trust that reported weather when you're deciding if you're going to be able to safely complete an instrument approach into your airport. Now, as time passes, automation is working its way into aviation at a rapid pace, and like anything else, understanding its benefits and limitations is very important.